Hello students, welcome to this lecture on the subject engineering mechanics. We will take another problem on coplanar concurrent force systems. Now in this problem, it's a two force system problem. Car is pulled by means of two ropes as shown in the diagram. The tension in one rope is given 2.6 kilonewton. If the resultant of two forces applied at point O is directed along the x-axis, find the tension in the other rope and also magnitude of the resultant. Now in this question, two forces are acting on this particular body at this point. Now one force is P equal to 2.6 kilonewton and it is making 32 degrees with respect to x-axis. Now the other force is acting whose magnitude is not known but direction is known. It is acting at 28 degrees with respect to x-axis. Now another information that is given is the resultant of these two forces is moving along the x direction. It is directed along x direction. Now in this problem we need to find out the magnitude of this force Q. Also we need to find out magnitude of resultant. Now this particular problem, because only two forces are acting at a point, we will be solving this with multiple methods. The first method we will solve it by using triangle law, then later we will solve it by using force resolution method. So in triangle law, we will use these two forces to somehow to make a triangle of forces. Now this concept is important, how we draw the triangle. Okay, so these two forces which are acting at this point, we will use these two forces as two sides of a triangle taken in particular order. Okay, so P now for this triangle, this P is acting like this, so we will draw a line parallel to this force P. Okay, so this angle is 32 degree, so simply we will draw one line that represents, this line of action represents the vector P. Now this force Q we will take from here, so we should take in the same order. So it is directed like this, so there should be an arrow here, so Q is directed like this. Then when we represent these two forces by two sides of a triangle, then the third side, which is the closing side, will be taken in the reverse order. So you see the direction of this resultant. This force is like this force is directed like this, and the resultant is directed like this. Okay, so this represents the resultant of these two. So we have represented these two forces in a triangle. Now within this triangle we'll apply either cosine rule, sine rule, okay, whichever is applicable for the given problem. Now from the given information, that is geometry, this angle is 32 degree. So this is the x-axis, 32 this was given, that means this will be 32. Another angle 28 is given, it is this angle 28. So therefore this angle will be 28. Okay, and this will be 120 degrees. We can find out this 120 by subtracting either 180 minus 32 minus 28 or 180 minus 32 from here. So it is the same thing. So ultimately we will get all the angles within a triangle. Now when we get all the angles within the triangle, the easiest formula that we can apply is the sine rule, because we know all the angles and one of the side is known, then straight away we can apply the sine rule. So you must be aware of this formula. Now if we take one force P, 2.6 kilonewton divided by angle, we will take opposite to that, so it is 28 degrees. If we take Q, this side, the angle that is opposite to Q is 32 degrees, so that will come in the denominator, sine 32. Then the resultant, the opposite angle for this resultant is 120 degrees, so that will come in the denominator. So this is how we write the sine rule for a triangle. Okay, now we can easily evaluate this. So you can solve Q, P into sine 32 divided by sine 28, we get 2.934 kilonewton, and also we can find out the resultant. So this is the answer. So if we can somehow manage to put these two forces with the help of a triangle, we can apply the sine rule or even cosine rule we can apply, and we can solve the problem. Okay, this actually becomes convenient, but we need to make triangle out of it. Now one can also think that we can make a triangle like this also. Okay, there can be more number of ways in which we can actually draw that vector triangle. Okay, you can see I have taken the resultant as given in the problem as along x-axis, then q like this, then p I have taken like this. Okay, because q is directed like this, so two forces I have taken in order. The third side, the resultant, is closing this triangle, and this represents a triangle of vectors where two forces are acting a common point, and the resultant is this. Okay. Again, if we try to find out the angles within these triangle, we will get the same result. There can be another way also of forming a triangle. Ultimately, we will get the same answers. So this is how we can solve by using triangle law. Now this problem can also be actually solved by using the parallelogram law also, that you can try. That means by using these two forces, we can construct a parallelogram. Then the diagonal of the parallelogram represents the resultant, and we can find out magnitude, even the direction. Okay. In fact, the direction is along x direction. So that also you can try. So remember, whenever the problem is of two forces acting at a point, it is first thing is to try by solving triangle law, that is sine rule or cosine rule, or even parallelogram law. Okay, we get the results very quickly. Now the next method that we will see is by resolving the forces. Now for particular problem, the steps are very less steps, but sometimes if the problem is little complicated, then by resolution of force, it becomes very tough, or it goes lengthy to get the answers. So therefore, whenever two forces are given, I generally prefer these methods, that is sine rule, cosine rule, and parallelogram. But still, you will get the answer by this method also. Okay. Now it is given that the resultant is directed along x-axis. The immediate conclusion of this is summation Fy is 0, because the entire force is directed, the net resultant is directed along x-axis. Therefore, the vertical component of resultant, which is summation Fy, is 0. Another is R is summation Fx. So if summation Fy is 0, that means 2.6 sine 32, the x component of this force, the y component of this force, that is sine 32. Then the y component of q, because it is going in the downward direction, minus will come, q sine 28. Okay. And that is equal to 0. So if we solve this, we'll get the answer q, 2.934 kilonewton. We are getting the same answer here. Then summation fx equal to r, because in the problem they have said to determine magnitude of resultant also. So therefore, the x component of these two forces, 2.6 cos 32, 2.6 cos 32 plus q cos 28 degrees, it is plus. Now we have already found the value of q in the previous step, that we can substitute, and we get the value of resultant 4.796 kilonewton, and it is approximately same. It is same. Okay. So either it depends how we are going to solve the problem. The approach is important. Okay. So anyway, you will definitely get the answer. So thank you for watching this video.